Hey Internet, welcome to Solid Mechanics tutorial. This is a made-up question not found in textbooks. We have two rods joined together, XY and YZ. The midpoint is Y, subject to a load. Side note, a load means it is a force. We have the average stress in both rods, both or either, must not surpass 300 MPa. Calculate the minimum permissible value for the diameters. So what's the smallest diameters you can have for these rods? Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. Next, list all the given values and the unknowns. This will help you figure out formulas. Step 2, find the formula for average stress. So we need this formula in order to find the area, which then we can find the diameter. Step 3, find the area formula for XY and then rearrange for diameter 1. So your area is pi divided by 4 multiplied by diameter squared. So d is diameter. So we rearrange for diameter squared is equal to 4 multiplied by p divided by pi multiplied by sigma. So where did p and sigma come from? They came from here. So that's what we needed to find this formula before we can find the diameter. Okay, so they give us the force. So it is a little bit confusing because they put force as P and pressure as sigma. And I know, why didn't they just use F for force? It would have made so much more sense. But apparently it was taken. Okay, so P in this instance is 120 kilonewtons for part A. So we're trying to find diameter 1. Okay, and sigma is 300 MPa. So step 4, we're going to find diameter 1 for XY. So the load force is 120 kilonewtons. Okay, and we're using the formula that we just found. 1 Pascal or 1 PA is equal to 1 Newton meter squared. So 1 megapascal is equal to 1 million Newton meters squared. So 300 megapascal is equal to 300 million Newton meters squared. So we start from 4 multiplied by 120 kilonewtons divided by pi multiplied by 300 meganewton squared. So what we did was we standardized the units, so we made them all into single Newton units. So then we just solve it normally. So from there we have to square root both sides to get diameter 1. So we square root this entire right hand side. So d1 or diameter 1 is 0.02256 meters, which is 22.56 millimeters. So we're going to round it up to 22.6 millimeters to 1 decimal place, 1 dp. So that is the answer for part A. For part B, we repeat the process for YZ. So we found the formula for stress, and then we're going to use that to find the area, and then we're going to rearrange for the diameter squared. Okay, so step 8, we're going to find diameter 2 for YZ. So note that there is 3 forces acting, so one's going in one direction and 2 in the other direction. So that's actually a negative. And we have to be careful. So I'm just going to go back up and just show you where the forces are, just in case you forgot. So we've got one force going this way, we've got two forces going this way. So we've got two 250 kilonewtons going here and going here. So they're pulling on the right and this one's pulling on the left. So we're going to have negative 380 kilonewtons right here. So we just rinse and repeat. However, we do need to be careful. Because it is a negative number, we have to have a negative 300 MPa. Because you can't square root negative. Well, yes you can. It becomes an imaginary number. However, an imaginary number doesn't help us in this instance because this is solid mechanics, not electrical engineering. So they both need to be negative, so it becomes a positive number in order to be square root. Okay, and our diameter, our D2, so this will be 0.040159, which is 40.159 millimeters. And we're going to round that to one decimal place, so it is 40.2 millimeters, 1 dp. So it is rounded up to one decimal place, which is rounded up to 1 dp. Okay, so that is part B, 40.2 millimeters. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Thanks for watching. Hope you had a great day. Be sure to like, subscribe, share with your friends, ring the bell, turn on all notifications. Leave a comment below if this was helpful or if you have questions that you're unsure about. If you want to support me, become a member or drop a super thanks. Until next time, see ya.